Okay, we're here at the Quasar Energy Group's digester complex that creates biogas, and I'm with Cody Montgomery, who, what's your role here, Cody?
I'm the sales account executive here, and I do a lot of pre-marketing research.
Great. So this facility here takes waste products and turns them into a biogas that we can use for energy.
Yeah, we'll bring in food waste. Some of our other facilities can take wastewater treatment plant sludge. We'll put them into our digester tank here. This is 550,000 gallons. Our other facilities would range from 1 million to 2 million gallons, so 4 times this size.
Wow.
This is just a small, sort of like a show and tell, sort of what we're doing today.
Okay.
So what we'll do is we'll bring in a truckload of material. It'll go into our receiving area. We've got 2 other tanks on the back side of this one that are 50,000 gallons apiece. The first one is a feedstock receiving tank where all the material that comes in goes into. It'll sit in there for a few days, about 3 or 4 days, to acidify and get rid of all the excess carbon dioxide, the CO2 in the mix. Once that's done, it'll be pumped into the actual digester where it's mixed continuously. It's got about a 30-day retention time. So we feed in about 20,000 gallons a day, pull out about 18,000 gallons of effluent or waste from the digester just to keep the volume in there equal. And the bacteria in there breaks down and obviously consumes some of the actual volume. So it'll sit in there for about 20 to 30 days being mixed up, producing gas. We'll harvest that gas off. It's a continuous process also. And here on campus, we have a generator, 650 kW generator. It'll produce about 1/3 to half of the OERDC ATI campus here. And then what we don't use there, the energy we don't use there, we generate compressed natural gas for motor vehicles.
So it sounds like there's a lot of stuff going on here. He's going to let us look at some of the facilities here, kind of explain how this whole process works, and you'll learn how they turn waste into renewable energy. Okay, so we're going to start this process. So explain to us where it all begins.
So what we'll have is we'll have a semi-truck with like a 6,000 gallon trailer pull up. The liquids will go in here. There's a liquids receiving tank here. It's about 20,000 gallons. It's underneath the concrete here. They'll load up and just use the gravity pressure on the truck to unload there. If it's a solid load, it'll be about a 20-ton or so trailer that will empty in here. They'll bring it in and it'll be a dump trailer. They'll empty it here, and this will mix in the solids with the liquid so we don't clog up any of the pipes or any of the drains or anything. That's pretty much here. That's all that happens here. So we're inside the building now. This is where most of the pumps and the equipment is located. So back behind us here, we've got the main pump that'll pump the feedstock or the effluent, depending on the rotation of the pump, through these columns here. These are heat exchangers that keep the material inside the digester at about 100 degrees Fahrenheit or 38 degrees Celsius. We found that that's the best temperature to keep the process going. When it's warmer outside, obviously we don't have to heat as much. During the winter, this keeps it at a constant temperature.
So we got to heat it to get the process of breakdown going? Is that what we need?
At about 39 to 100 degrees, 39 degrees Celsius, 100 degrees Fahrenheit is the optimum process for digestion for a 30-day retention time. If you wanted to shorten the retention time, you'd increase the temperature to 140 degrees Fahrenheit or so. But then you're not getting as much energy output. You're not getting as good quality natural gas and the methane coming off of the facility. So we found that this gives us the maximum potential for tip fees, what people pay us to dispose here, and then the actual energy output going to the campus or to the network.
So then once it's heated, then it goes down the pipes, and then it goes where?
Then it goes into the digester.
Goes into the digester. So let's go look at the digester next. We're out here at the digester. That material that we just talked from the heat exchanger, then it gets taken out here, and then what happens?
These valves basically control the flow, so we don't have backflow back into the building. But then the material comes in here. This is the feedstock tank where we talked about out front there a little bit, where it'll sit for 3 days or so. And this is mixed continuously also because we have such a variety of feedstock, different waste coming in. We'll have a fruit waste, we'll have a grease trap load, we'll have septic waste coming in. So we want to make sure that's all mixed up well, so that when we put it in there, we don't have pockets where we have residue settling or something like that happening. So once it's sat in here, it'll go into that tank over there. That's continuously mixed. So we have our mixer here. This is constantly running. We've actually got 3 of these located all around the digester tank. The better the mix, the better the production of energy will be. If we have it just sitting in there, then the heavier material settles to the bottom, lighter material, and the bacteria float to the top, and we lose a lot of the energy value that's in the heavier material sitting at the bottom.
Okay. And that churns for how many days?
The material being here for roughly 25 to 30 days, continuous mixing, the mixer never turn off. And as I said before, we're feeding in about 25, or depends on what the feed is, it'll feed in about 15 to 25,000 gallons a day here at this facility. We'll pull out just a hair under that, and we'll go into that third tank over there, which is the same size, pretty much the same mixer and valve process at this tank.
So it stays in here for 25 days and then it goes to the other.
Yes.
The other side over there. So once it's done in the main digester, what's left over comes to this.
Yes.
Okay. What do you do with the material that's in here?
The material in this tank we'll use as either to start a new facility when we have a new one come online, or the local farmers in the area will come and use it for fertilizer for their fields. It's a Class B fertilizer, so it's a pretty high grade fertilizer. The only higher grade is a Class A, and we're working on technology right now that'll allow us to do Class A. Once it's a Class A waste, we can sell it to like a Hypenex or somebody like that who can make like a Miracle Grow type potting soil out of it and sell it at Walmart or wherever.
Okay. So how much waste is usually transferred at a time?
It's almost the same as the feedstock coming in.
So it's even going in,
yes.
going out.
Yeah,
Okay.
it's just slightly less because of the breakdown and the decomposition of materials in the digester tank.
Now you talked about sometimes you use this material to start a new facility. Is that because of the bacteria that's
Yes.
in the culture
Yes.
that you need to digest it? And so that bacteria is still in there.
Yeah.
And that bacteria, a lot of times people hear bacteria and they think, disease or anything else. So this is a beneficial bacteria that even though it's used as a fertilizer is still harmless?
Yeah, it's the same. It's pretty much the same bacteria that starts, it's in a cow's stomach.
Okay.
Basically, our whole process is to mimic what a cow's stomach does.
Okay.
The bacteria will digest it, and then we're capturing the gas off of that, like a cow would have after eating.
Right.
So it's the same process, and then the bacteria is perfectly harmless, other than breaking down the material.
So we went through the process. We've taken the food waste or the manure, whatever that waste feedstock is. We've taken it through. We've put it in the digester. Once it's in the digester, it then creates that biogas, which is really what this whole process is about. So now let's go talk about what happens with that biogas and how we can use it. Okay, so we've created that biogas. Now we're going to use it. So what's behind us here is what?
This is our generator right here. It's a 650 kW generator. It's about the equivalent of a V24 engine. The generator just takes that gas and burns it directly to generate the electricity. We'll generate about not enough energy to power about half of the OERDC campus. It takes about 1.5 megawatts, 1.3 to 1.5 megawatts a day. We'll generate about half of that every day. And then this also produces heat. We use that heat to run the heat exchangers inside, and then in the winter we have loops of hot water that run underneath the concrete in our system, so we don't have to plow the concrete with the hot water running underneath there.
So we're going to go inside the generator and see what's in the inside and how this all works.
Okay, so we're in the control room of the generator. This lets us monitor everything that's going on. This will show us power we're producing, the RPM the engine's running at. We've got a monitor here that shows us the flow of gas that's coming through the generator. And everything can be controlled from in here. Turn the generator off, turn it back on. We need to do routine maintenance.
And then this electricity then goes out wires to then feed the campus.
Yes. Yep.
That directly goes to the campus. So we're going to kind of step into the generator room. Obviously we're not going to talk, it's very loud. I understand there on the door it says caution, ear protection area. So obviously we're not going to do a lot of talking in there, but we want to at least let you see what the generator looks like and maybe give you an appreciation of how much noise is in that room. So let's check that out. Alright, here's the generator. I told you it's loud, ain't it? Basically this is like a diesel engine, it's there. So that runs 24/7? 24/7. So we're not going to stay in here very long because we won't be able to hear anything when we leave. Okay, so tell us what we're looking at here.
This is where all the gas comes to once it's been through the digester. It goes through here, it gets cleaned up through all this process. We have several different processes here because this facility is sort of a show and tell facility. We bring everybody through here, the important clients, educational purposes through here to show them what we can do. So if there are interests in the future, for students looking to get a job in this field or clients looking to build a digester at one of their locations, they can see what we can do. So the gas is cleaned up here, then it's pumped into the generator, or it goes to our CNG on the other side.
Okay. So this comes in, the methane, some of it's sped into the generator.
Yeah.
And then you said you have the CNG, which is
Compressed natural gas.
compressed natural gas. So some of that methane then is produced and put into, does that process happen right here?
Yeah,
or
it all happens right here, and then it's piped around to the backside.
Okay.
Our process, the first amount of gas that comes to this is about 60% methane. We clean it up, we get it to about 99% methane, which is the CH4, the compressed natural gas that we're after.
And then you can use the compressed natural gas for
just about anything.
Anything that
replaces natural gas, just about anything.
And you said you have a pump over here that you use for
yes,
the vehicle?
a fueling station.
Well, let's go check that out. So this is the pump for your natural gas, right?
Yes.
So this basically comes from the cleaning station, and then this is used for...
This is, we can use this for motor vehicle fuel. As you can see, there's a sticker there that says the minimum for CNG is 90% methane. We obviously, with 99.4, 99.5% methane, we're doing pretty good with that. These are quick fill stations. A normal CNG fueling station would take like overnight to fill. We can fill in about 20 minutes, 30 minutes in our facilities. Right now, only 2 of our facilities are open to the public for fueling. Most of the other ones are for truckers. We have our trucks, and some of the truckers that come in, their vehicles run on CNG, and we've seen a savings of about 20% in vehicle fuel for those, as far as improved miles per gallon, and then just the cost of fuel. We can charge about $2 per gallon here, as opposed to $3.50 to $4 for regular gasoline.
Wow. So we went from basically food waste to being able to fuel your car or produce electricity, all from waste products that we have here in Ohio, whether it's farm waste, food waste, or even human waste in terms of the sewage. We can turn that waste into a renewable energy source that is a way to power the needs that we have as a society. That's pretty cool.
It is.
I appreciate your time.
Yep.
That's been a great education. I hope some of our students have learned more about how we can take these waste products and produce usable renewable energy. And I'm really excited to see what this does in the future.
Cool.
Thank you.
Thank you for coming out here.